Hello everyone. So in this video, I'm going to go over some of the problems in the final exam study guide. So if you want to follow, please get your study guide. And because this is a video, you could pause at any time and then work with me throughout this video. Uh, yeah, and then send questions to me if you have any. All right, so let's start with the first one. What is the critical z-value used to create the following confidence intervals? So this critical z-value is what you use, the same z-value you use in your confidence interval formula. Now, to find the z values, you have to go to the table or the chart, the z chart. Now, I'm going to show you where to find uh, your critical z values in the chart. So let's go to the chart. So I find my Z chart. So this is the positive one. Now, right here, you have the confidence interval critical values Z. So in the study guide, the first one we're supposed to find is the critical Z value for 80%, which is 1.28. And then we have 90%, which is 1.645. And then we have 95%, which is 1.96, and then 99%, which is 2.58. Now, this is the same chart you're going to have on the exam. All right, let's quickly go to number 2 in the study guide. So in problem 2 on the study guide, assuming all else is equal, what is the key impact confidence level has on the width of a confidence interval? So in this problem, you've got to take your time to read it to understand it. So assuming that all else is equal, that is with the confidence interval formula, everything is equal. Now, it says all else because it's referencing the confidence level here. So if everything else is equal, what is the impact, the confidence levels, which we have in problem 1, the confidence levels have on the width of the confidence interval? Now, remember that in the confidence interval, there are always two values, right? The lower limit or the lower bound, and then the upper. So the width of the interval is going to be the upper minus the lower, because you want to know the width of that interval. So let's say that my confidence interval was 28.2 to 42.9. So my width is going to be the difference between the two numbers or the two limits. That is going to be my width. So you put this in the calculator, 42.9 minus 28.2, and then what you get will tell you the width. Now, we want to know, how does the confidence level impact the width? So let's say that if the confidence level increases from 80% to 90%, or from 80% to 95%, what is going to happen to the width? Is it going to get bigger or is it going to get smaller? Now, to try to break this down, I'm going to use the confidence interval formula for the mean. So confidence interval of the mean. So I have X bar, which is my sample mean, plus or minus my critical value of Z. Remember, I get this from my confidence levels, right? My confidence levels. standard deviation over square root of n. Now, the plus or minus gives us the width, right? So you have the sample mean, you find the margin of error. This is the margin of error, which is represented by an E, and that is the margin of error. So you find your margin of error, and then you add to the sample mean, you subtract it from the sample mean. Now, assuming all else is equal, which means that we're going to say that these will stay the same. So let's start with an 80%, 80% confidence level. From the chart, 80% is 1.28. So this Z here, this Z becomes 1.28. So you are multiplying the Z value to whatever you have here, which is going to stay the same. So if I want to try to make this simpler, I'm going to say, let's say my sample mean is 60, plus or minus my Z times, let's say, 5. Now, if I start with an 80% confidence level, the Z is 1.28. So I'm going to have 60 plus or minus 1.28 times 5. And this is for 80%. Now, 1.28 times 5, that is going to give me 6.4. 6.4. So I add 6.4 to 60, and that gives me 66.4. And then I subtract 6.4 from 60, and that gives me 53.6. So my two values, the minimum or the lower limit is going to be 53.6, and then the highest is going to be 66.4. And remember, this is for 80%. Now, let's say I increase my confidence level to 90%, and 90% is 1.645. 1.645. So my Z value is going to change from 1.28. I'm going to erase the 1.28, and then I'm going to put in 1.645 for 90%. 1.645. So 1.645, oops, times 5, that gives me 8.225. So for 8.225, I'm going to rewrite this. So I had, for 80%, I have 53.6 and then 66.4. Now, for my 90%, I'm back to the 90%. I have 8.225. Now, if I add 8.225 to my 60%, that gives me 68.225. And what about if I subtract 8.225 from 60? That gives me 51.775. So right there, you would see that if you subtract the lower from the upper, you will see that from 80% to 90%, the width, the difference is getting wider. Now, if you go to 95%, again, it's going to get wider. So this means that as confidence levels increase, the width of the confidence interval increase. As confidence level decrease, the width of the confidence interval is also going to decrease. So increase, increase. So they're going the same way. Increase, increase, decrease, decrease. Right? And of course, on the exam, it's not going to be the same problem, but you have to, that is why I'm taking my time to go through these so that when you understand it, even if the problem changes a little bit, you should be able to do it, or you should be able to solve it and get the understanding from it. All right. Now, let's go to number 3. Which of the following impacts the margin of error of a confidence interval about the mean? So we want to know which of the following would have an impact on the margin of error of a confidence interval about the mean. So again, the formula for confidence interval about the mean or of the mean. So I'm going to use the z. So this is x bar plus or minus the z times the standard deviation over square root of n. And remember, this is the margin of error, E. So if you want to know which of the following would impact the margin of error, now we have the the critical value of Z, which we get from the confidence level. So the confidence level affects it. The population standard deviation would affect it, or the standard deviation, because you could have a T where you do the sample standard deviation, and then you also have the sample size. So three would affect the margin of error. So it's just about knowing the formula of the margin of error, and that should help you know the stuff that are in the formula, which would affect the value of the margin of error. All right. Number 4. In this formula, you would find the formula in the formula sheet, which is given to you on the exam. You'll find the formula in there. All right. Number 4. Compute a 90% confidence interval for the proportion of heads observed if we flip a coin 100 times and observe 65 heads show up. So we flip a coin 100 times. So our sample size is 100 because we're doing this over and over 100 times. And then we observe 65 heads. Remember, we're trying to find the confidence interval for the proportion of heads observed. So our success is going to be when we flip the coin and then get a head. That's a success. And that is why it says we observe 65 heads out of the 100. All right. Now, this is a confidence interval for proportion. So you have to go to your formula sheet again and then find that formula, confidence interval. And it's right here, confidence interval Z distribution proportion. So you use this formula. All right. So let's go back. So we're going to write the formula out here. So this is a p hat, which is the estimated p, or the sample p, which is the proportion, the estimated proportion, plus z. So we're going to use the critical value of z times square root of p hat, q hat. So these two are multiplying, divided by n. There's an n. All right. So I've got to find my p hat. I've got to find my q hat. I've got to find my n. I've got to find my critical value of z. Let's see. Now, to find the z, it says a 90%. So 90% confidence interval. So my confidence level, I'm getting 90%. So I'm going to use that to find my z value by going to the chart again. Now, if you go to the chart, remember that is question 1 on the study guide. 90% confidence level gives you a z value of 1.645. So my z is 1.645. Now, what about my p hat? Now, p hat is the sample proportion. Now, if you think about proportion, what should come to mind is a fraction or a decimal or a percentage. Fraction, decimal, percentage. Now, if you go back to the formula sheet, and then we're going to look at that sample proportion. It says R over N. That is for a p hat. And look at q hat, 1 minus p hat. It's right here for you. So we're going to use this. Now, the R is the part, and the N is the whole. The N in this case is going to be our sample size. Our part, in this case, our R is going to be 65 hertz observed out of the 100. And this gives us our proportion or our fraction. So going back to the problem. So my P hat is going to be 65 over 100, which is 0.65. Okay? So my Q hat, we also saw that Q hat is 1 minus the P hat, which is 1 minus 0.65. And Q is always 1 minus P. Okay? As a complement. So of P. So it's always going to be 1 minus, which is 0.35. So I've got my P hat, I've got my Q hat, I've got my Z, I've got my N. And those are the stuff I need to solve the confidence interval, for the confidence interval. So I'm going to repeat the formula again so that you follow what I'm doing very well. So P hat is 0.65 plus or minus. My Z is 1.645 times the square root of P hat is 0.65 times 0.35 over 100, like that. Okay, so there's what I have. Now, you have to go to the calculator and then solve this. And please try to practice and practice on the calculator, because if you get the formula right and you don't know how to put this in the calculator, you are still not going to get it right. And you're going to get frustrated. So make sure you keep practicing. All right, so I'm going to go and then do the square root first. But because the whole thing, 0.65 times 0.35 divided by 100, all of that is under the square root. I'm going to solve that first. So let me share my calculator. I'm going to solve for that first. Okay. So let's see if this is going to show up. Okay, there we go. So I have 0.65 plus or minus 1.645 times 0.65, 0.35 over 100. So I'm going to do 0.65 times 0.35 divided by 100 equals that. And now I apply the square root. So the square root of that gives me 0.04769. So right now, I'm done calculating for this here. So I have to multiply what I get by the Z value, 1.645. So I'm going to do times 1.645 equals 0.07846. At this point, you can round. So, and depending on what the problem says, so we have 0.65 plus or minus 0.07846. Then I add that to 0.65. And then after I subtract that from 0.65. So you could do whichever one first, but I'm going to do the addition first. So plus 0.65, just because adding is not going to give me a negative. So I have 0.724. So that is going to be the bigger one, 0.2725. And then the smaller one would always be on the left. So I'm going to repeat it, 0.65 minus 0.0784, 846. All right, and that gives me 0.5715. So that becomes my confidence interval. All right, so I'll see you in the next video. I hope this helped you. Keep smiling and keep practicing. Bye-bye.